I want to take a look at a couple of vector functions that map us into 3 space that we're going to be able to graph. Now, I'm not expecting that we will be able to generate graphs of all of the vector functions that we encounter this semester. Graphing curves in 3 space is a lot more complicated than what we've done in 2 space, and there are going to be plenty of functions that will work with algebraically but not graphically. But this one's an example right here of something where I can take advantage of my familiarity with the unit circle in 2 space to figure out what this graph looks like in 3 space. Okay. So if I take a look, cosine of t, that's giving me my x value. 2 is my y value. So the component function for y is constant, and sine of t is giving me my z value. Okay. Well, the fact that my y value is constant tells me that the curve lies in the plane y equals 2. So it's going to be a plane curve. It just lives in a different plane than the xy plane. It lives in the plane y equals 2. But I know that that's just parallel to the xz plane. So I'm going to start by drawing this curve in the plane y equals 2, and then we'll transfer our findings to actually graph that in 3 space. Okay, so if I'm in the plane y equals 2, I've just got cosine t, sine t. Looks like the unit circle to me. And notice cosine is for the variable that I have on the horizontal axis, and sine is for the variable that I have on the vertical axis, so that's going to be counterclockwise as I've drawn things right here. Okay, so what does that look like in 3 space? Well, remember, here's x, y, and z. So we come over to, we're looking at this plane over here, y equals 2, that would be parallel to the xz plane. So we're just going to see a circle over here that's centered at this point, 0, 2, 0, on the y-axis. I'll draw in the orientation in a moment. Let me just show that if I wanted to really clarify that that is on that plane, y equals 2, if I wanted to, I could go ahead and actually draw that plane. Remember how we've done that is we would say, okay, so I'm going to draw in this line that's parallel to the x-axis and parallel to the z-axis, but through the point whose y value is 2, to make it super, super clear that that's the y value determining this plane. Okay. And then the way we indicate a plane, of course, is with parallel lines. So I'm drawing parallel lines, 2 parallel to the x-axis, 2 parallel to the z-axis, and that's just my plane y equals 2 right there. And then on that plane, I have this circle. Okay. All right, now that picture gets a little bit busy. I almost like this one a little bit more, but I could sort of tweak things and decide what I liked the best. Now let's include the orientation. I have to be very, very careful because we said it looked like it was counterclockwise here, but what does that actually mean? Well, that means that if I start on the positive axis that's parallel to the x-axis, this isn't actually the x-axis because it's the line in the plane y equals 2 parallel to the x-axis. If I start where x is positive, I'm moving to where z is positive. Now in 3 space, x being positive is forward and z being positive is up. So I'm starting forward and moving up. So it would be looking something like this. It almost looks clockwise, but it's actually this picture just put on this plane when I lift that into 3 space. Okay, excellent. So let's try another example. Let's take a look at, I'm going to keep my x function cosine of t. Let's take a look at r t equals cosine t, sine t, t. Okay. Now, if I ignored the z values, that just looks like the unit circle oriented counterclockwise, okay, in the xy plane. Okay. But now I'm attaching a z value to it. Okay. And as t increases, z increases. So it's almost like I'm drawing that unit circle, but as I draw it, I'm lifting the pen. So I'm moving up as I draw. So let's see what that would look like. Okay. So here's 3 space. At time 0, just to give me a nice starting point, although I'll then extend in the opposite direction because t can be negative. At time 0, I would be at the point 1, 0, 0. I'd be on the positive x-axis. If my z value stayed at 0, I'd be drawing this counterclockwise, so I'd be approaching a point that would be on the positive y-axis. Because if you think about it in 2 space, we start here and we come to here. Now the positive y-axis is over here, so I'm going to be drawing my circle sort of like so. Okay. But as I draw it, I'm going to be moving up. Let me draw in my orientation. So that's going around the z-axis. Looking from above, it looks counterclockwise. Okay. Moving up as we go. And that's just giving me this helix, and then I can extend it, because of course t is allowed to be negative, so it extends below as well. Kind of a neat curve. I like it. Okay. So those are just a couple examples of some of the curves in 3 space that we are going to be able to draw. We won't be able to draw all of them. Some of the homework does ask you to sketch some curves, and so you want to try and figure out, but you're often looking for, do 2 of the components give me something familiar, and then how does the third component change that? In the last example, the third component just was the y component, and that put us in the plane y equals 2. In this example, the third component is the z component, because that was what was familiar, and that just said, hey, I'm not drawing a circle in a plane, I'm drawing circles as I move up. And that gives me this spiral or this helix.